In this video, we're still looking at grade 12 compound angle identities. Okay, so we're going to solve the following two questions, right? So the first question, I'm going to write it here. They say prove that sine 75 degrees, right, is equals to this. Okay, let's try this question, ladies and gents. Okay, so here I know that, okay, I have 75 here, right? I have 75, okay? So this kind of questions where they say without using a calculator and they just give you one angle, obviously you're going to be thinking of special angle. So I'm thinking of 0, 30, right? 45, 60, 90, and so on, right? Perfect. But the most interesting thing about this one is I see that, okay, if I add these two special angles, right, I'm going to get this exact value there, which is very exciting. Do you see it? So sometimes when you minus it, it's going to give you this number. Sometimes when you multiply one special angle by 2, which are double angles, we're still going to get there. Eh? But so you're firstly going to check, are there any two special angles that when I add gives me 75? If they aren't, you check for subtraction. If they aren't, you check for multiplication and so on. But this one was easy. We could easily see that 30 and 45 are going to give us 75 when we add them. So it's sine 45, then it's minus, it's plus 30 degrees there, right? So I just represented this expression in this form. It's still the same thing, right? Perfect. And then from our compound angle identities, let me just take them and bring them down. Let me just take them and bring them down for those who haven't learned them yet. So I can see that, okay, here, right, I basically have this identity. Let me get my pen. I basically have this identity. Sine 45. Okay, let's do this. So our alpha is 45 in this case, and then our beta is 80. So where there's alpha, I'm going to put 45. 45. Then where there's beta, I'm going to put 30. 30 sharp. So which means this part I already wrote it at the top. Do you see it? Is here. So I'll just write the right-hand side now. So we have sine 45 degrees, cos 30 degrees, and then we have plus cos 45 degrees, and then we have sine 30 degrees. Remember, I told you the strategy of working with special angles. You don't just press everything at once, right? You do it one by one. Sine 45 will give you root 2 over 2, right? Then cos 30 will give you root 3 over 2 when you press them on a calculator, right? Then cos 45 will give you root 2 over 2. Then sine 30 will give you half, right? Perfect. And then you're going to now multiply here. If you press this on a calculator, right, this part must give you root 6 over 4. Because here, root 3 and root 2, when you multiply them together, they give you root 6, and then 2 times 2 at the bottom gives you 4. And then there you must have root 2 over 4, right? Then now let's check what do they want at the top, right? At the top, they want us to have this, okay? So the interesting thing here is this, right? My lowest common denominator is already the same. So I'll just write 4 there. And here I have square root of 6 plus square root of 2. Right. Now, okay, I see that, okay, I have to take a square root of 2 out here. If you check it, I must have a square root of 2 out, right? So this is what you're going to do then. You are going to break square root of 6 into square root of 2 multiplied by square root of 3. So I'm taking it back there. You see, remember 6 is 2 times 3. And now according to the laws of exponents, I can write it in this form, right? And then plus square root of 2 all over 4, right? And then from here, I can now factorize a common factor out, right? Which is square root of 2. If I'm factorizing here, I'm going to be left with square root of 3. Then this plus sign is there. Here, if I cancel, I'm left with 1. All over square root of 4, which is equals to right-hand side. So we have shown that sine 75 can be written in this form without using a calculator. Okay, now we're going to do this one. Hey, let's quickly create space for writing. So this part must go away. All this must go away. Okay, all this must go away. Marvelous. So let's do number 2 now. Number 2, they say 2. So they say determine the value of the following expression without the use of a calculator. Okay, remember I said this kind of questions, you always have to check your answer at least so that you expect what answer you are supposed to get, right? Let's check now. So you have cos, so we have what? We have cos 65. We have cos 35 plus cos 25. And then we have cos 55. Okay, this gives us what? Approximately 0.8660 and so on, right? The answer that we get, we're going to check if it's very close or exactly the same to that one, right? Perfect. Then now we can proceed. So now, okay, this question, right? Let's see. Remember, I need the angles to be the same, but my angles are not the same. My angles are not the same. Here I have 65, I have 35, I have 25, I have 55. And I cannot do reduction because the angles are already less than 90 degrees. So I'm going to use this idea. Remember, if I have cos 1, right? Then I'm going to be having sine 89 this side. These two will be equal y. As long as the angles add up to 90, sine and cos are the same. I can prove to you on a calculator, right? Let's say we had sine 5. Record the answer. Obviously, we need to use cos 85 so that 5 and 85 add to 90, right? Let's see. Cos 85. Exactly the same answer. Do you see it? I can show you. Let's check the previous answer. So you press alpha, then previous answer. It's exactly the same. So if sine and cos have the angles that are adding to 90, respectively, then the sine and cos must be exactly the same. So here I'm going to use this idea. I'm going to try to change everything first. So cos, so cos 65 will go with sine 25. I'm sure we can all see why, because 65 and 25 add up to 90, right? Then cos 35 will go with sine 55 degrees. Right? Why? Because these two angles add up to 90 and then have sine and cos, so they have to be exactly the same. And ladies and gents, this is exciting. I'm just going to stop here. Why? Because I have 25 here, I have 25 there, I have 55 here, I have 55 there. So I have my pairs, right? So far I have sine 25 degrees, sine 55 degrees, plus cos 25 25 degrees, right? And then cos 55 degrees. Okay. So, which is exciting. Remember, if I see sine, cos, I know that it has to be which identity? Okay, let me bring this up so that you can see. Okay, I think it's fine here. It's either going to be this one or that one, right? I just need to rearrange and bring the cos the left side because it's always starting with the cos. Do you see? So this part must be the first. So I'm going to have cos 25 degrees, then cos 55 degrees plus sine 25 degrees sine 55 degrees. Right. And then, so remember the one with a plus is this one, right? So which means I have the first one, basically. This is the one that I have. So I know that if it's a plus outside, it means inside we're going to have a minus. So I have a cos, right? Then I can see that my alpha is this angle here, which is that one in this case, right? So it's going to be 25 degrees. Then I see that, okay, if I have a plus here, just like in this case, I must have a minus in the bracket. So I'm putting a minus there, right? And then I'm seeing that, okay, my beta must be here. So my beta is what? My beta is 55. So I'm going to have 55 there, degrees, right? Then I can simplify this to say cos 25 minus 55 is negative 30 degrees, right? Remember, negative theta is here, so negative 30 is in this quadrant of cos. So the quadrant of cos must be positive, right? So in this case, I have a cos, and I'm in the quadrant of cos. So my final answer must be positive cos 30 or positive cos theta, you see? Where theta in this case is my 30 degrees, right? Then what is cos 30 on a calculator? If you press a calculator, cos 30 will give you √3/2, right? Because 30 is a special angle, so you can easily get its ratio on a calculator. So now we're going to verify if √3/2 is indeed that value there. If it is, then we know we're correct, and then we can proceed. Okay. So now let's check. Square root of 3 all over 2. And then USD. Then you can see that you have the very exact number. Do you see it? You have the very exact number as that. You see it? This. And your answer there, they are exactly the same. And then you know that's finito about this question. Ladies and gents, as always, I'll see you soon. Please, if you have not subscribed, do so, because more fire content will keep on coming. And don't forget to share with family and friends. I'll see you soon. A luta continua. Tango.